So for 38, we want to set up the integral where we revolve the area between these two curves, which is this chunk right here. And we want to take that and then we want to revolve it about the line y is equal to 3. Now we're not actually going to calculate the integral. It's telling us to use a computer algebra system, but we do have to set it up. So I used a graphing calculator to set these up, and we can see that these lines intersect between x is equal to 0 and x is equal to 2. Now it's telling us to revolve about this line, y is equal to 3. So let's draw that in. It's telling us to revolve it about this line. So when we revolve it here, we're going to end up with a washer where the smallest part of the radius is going to touch that red line, so this line here. It's going to go like this. And the biggest part of the radius is going to touch that blue line here, and it's going to go like this. So basically our area is going to be, our volume is going to be comprised of summing up these disks, and we're doing a horizontal sum, right? We're summing them up from x is equal to 0 all the way up to x is equal to 2. And so if we sum these up, we're going to get a bunch of disks stacked across horizontally, and that is going to give us a volume. So what we're going to do here is we're going to set up our integral that goes from 0 to 2, and basically we have to find the volume of that disk. So the volume of that disk is given by taking a bigger circle, right, that has the biggest volume here. And actually I did that with different colors. I should have done it a different way, but basically, so let me use a totally different color to not confuse you guys. So basically I'm going to take the biggest circle here, and then from it I'm going to remove a tinier circle at the middle, sorry. And if I remove it, I'm going to be left with this ring here, which is what I want, right? And this ring here is going to give us our this is A1 minus A2, where A1 has the radius R1 and A2 has radius R2. So if we remove it, maybe I should have drawn everything here in green. If we remove it, we're going to get a green disk that is going to revolve like so. Yeah, maybe that's a little bit better. So we have to figure out what A1 is and what A2 is so that we can remove the smallest area from the biggest one. That will give us the ring, and then we can sum up those rings. So let's think about how we're going to get that. Well, basically, A2, sorry, I'm going to begin with A1. A1 is going to be, it's the distance between, let me put that in yellow maybe, it's the distance between the center here all the way to where it touches the red curve, right? Because where it touches the red curve, that's going to be our smallest radius. And I'm going to have to erase this for a while so that you guys can see it a little bit clearer. So if I have my line here, basically A1, actually, yeah, A1 is the biggest one, so I got that mixed up. A1 is going to go from the center here all the way to where it touches that blue curve, right? That is going to be our biggest radius. However, this point here is not the value of my function, because actually the value of my function, it is measured from way down here all the way to up, right? So that's the value of my function. It's not the blue line, it's the pink line. So to get the blue line, what we're going to have to do is we're going to have to take this distance of 3, and then we're going to have to subtract the value of the function. So if I take it 3 and I minus this little chunk, I'm going to get the blue arrow, right? So the blue arrow is just basically the distance 3 minus the height of the function, because the height of the function is where it touches the graph from 0 all the way up. So we can see here that the radius, the biggest radius where it touches this line here, goes like this. A1 is basically pi. The radius, once more, it's 3 minus this chunk, minus the height of the function. So 3 minus x, because this value is just x, right, squared. That's our biggest radius. Therefore, A1 is equal to pi, and I'm going to expand this. that is x squared minus 6x plus 9. And now let's think about a2. So a2 is going to be given by the distance between this line here all the way out to where it touches the red curve. Yeah, and once more, where it touches the red curve is not actually the value of its height, right? Because the value of its height, it would be from like here all the way up there. So it's not the value of the height, but it's 3. That whole thing is 3 minus the other purple curve, right? And the purple curve is the height of the function. So 3 minus the height of the red function, and that will give us this orange little arrow that we want. So a2 is going to be this distance here, this 3, minus the height of the function, minus the height of the function. So if we remove that, we get the downwards pointing arrow. So it's pi times 3 minus, and that one is, let's see, x e to the 1 minus x squared squared. Now let's FOIL this out. This one's going to be a little complicated maybe. So that's 3 minus x e to the 1 minus x squared times 3 minus x e to the 1 minus x squared, x over 2, sorry. So when we FOIL this out, we get, and that gives us 9 minus 3 times this, twice, right? So minus 6x e to the 1 minus x over 2. And then let's see, when we take this one, we're going to have plus x squared. When we take exponents, when we multiply these, we just add the exponents. So 1 plus 1 gives us 2. X squared times e to the power of 2. And then minus x over 2 minus x over 2, that just gives us 2 minus x. So all we have to do now is get a1 minus a2, right? So a1 is this stuff minus a2. This is going to be quite lengthy, so let's do that. So we're going to put pi outside, and then we're going to do a1 minus a2. So a1 is x squared, and then minus 6x. And here we're going to have plus 9 minus 9, so these disappeared. So we're just going to have now minus a2, so minus is plus, so plus 6x e, 1 minus x over 2, and then minus, right, minus x squared e to the 2 minus x dx, yeah. So once we have this, we are ready to put this in the computer, right? It's going to solve this integral for us. We don't have to do that work. And so when we put it into the computer, let me plug that in. I'm using Symbolab, and this gives me an integral of, let's see, pi times negative 2e squared plus 24e minus 142 over 3. And yeah, that is my answer, what I get when I revolve this area about the line y is equal to 3.